Welcome to this video, and we are still performing operations in logarithms of base 10. Today we are going to be learning how to multiply two numbers using our logarithm tables. Of course, these are straightforward calculations we can perform with our calculator, but the aim of this is to show that you can still use logarithm tables to perform complex operations in multiplication even when you don't have a calculator. Alright? So we have a question on the board that tells us to use logarithm tables to find this 25 times 25, 76.7 times this, and also this. Alright? So let us look at the first one, which is 25 times 25. Now, we can use our logarithm tables to solve this. Now, the first step I want people to memorize when performing operations, always learn how to draw a table. A simple table that says, this is it, number and logarithm. Alright? We are going to be using this table a lot when performing operations. This table helps you to just simplify what you are solving, so that even the person who is looking at what you are solving will understand what you are doing, and you yourself will not get confused while solving. So this is number and this is logarithm. So in this section is where we put these numbers, alright, that are from the question. Why this is after we are going to logarithm table to check, alright, we will then put it under the logarithm section. So it's as simple as that. Now, 25 times 25. So the first step is to write the first number that comes here, 25, and then we are going to find the logarithm of that 25. I believe you've watched my previous videos on how to convert numbers to logarithms. So we will not spend so much time explaining that, alright? But for the sake of this first example, we've seen that when you want to convert a number to logarithms, the first thing you do is to convert it to standard form to get the first part of your answer. And 25, which is same as 25.0. If you want to convert it to standard form, you have to move the decimal points to be between the first two digits, 2 and 5. How many times did I move? Just once. So my answer will start with 1 point. And then for the other part of the answer, I'll go to my logarithm table. What am I going to look for? I have just 2 digits. So I'm going to look for just 25. Remember to call the first 2 as 1. Call them together. 25 under, there's nothing else. So 25 under 0. Alright? So when I go to my logarithm table and I look for 25 under 0, that's going to give me 3979. So I'll put this here. There is no under, there is no difference, just 25. This is it. So this is the number, the first number, this is the logarithm. Now take notes, just as we've learned in our previous laws of logarithms. Since these two numbers are multiplying each other, when two numbers multiply each other, what happens to their logarithms? Their logarithms add. Please let that be something you familiarize yourself with. When two numbers are multiplying, their logarithms will add up. We've done it in our previous videos. Alright? So when I put times here, I'll put plus here. What is the second number? It's also 25. We'll also look for the logarithm of 25, which we have gotten already before as 1.3979. Alright? Now, what do? I add those two numbers up. Adding these two numbers up gives me 2.7958 when you add them up. So this is your answer, 2.7958. But your answer is still in the form of a logarithm. We need to convert our final answer to come here to be a normal number, because the question was given to you as a number. We don't need our final answer to be a logarithm. So how do we convert from logarithms back to a number? You got it right. We are using our anti-logarithm tables. Alright? So if you do not know much about anti-logarithm, check my previous video I dedicated to explaining how to use an anti-logarithm table. So an anti-logarithm table helps us to convert a logarithm back to a number. So using these anti-logarithm tables, I'm going to also use this first example to spend some time familiarizing you guys with how to use anti-logarithm tables. The first thing about converting a logarithm to anti-logarithm is the number that is before the decimal point, you keep it in your pocket. So we're going to keep these two in our pockets, we will need it later. And then we are going to go to our anti-logarithm tables for these other numbers after the decimal point. And we are going to use anti-logarithm tables to find them. Don't forget to call these two numbers together. And then this will be 79 under 5 difference 8. 79 under 5 difference 8. So when we check our 79 under 5 in our anti-logarithm tables, we are going to have 6237, right? And then when you check difference 8 is 11. So when you add 6237 plus 11, you are going to have 6248. So our converting this number to logarithm gives us what? 6248. What's the last step? These 2, which we have put in our pockets, we are going to bring it out from the pocket, and it's going to help us to know the position of our decimal points. As we've said before, this is our 0 position. That is, if this number was 0, this is where the decimal point should be. As a standard form, it should be between the first 2 digits. But if it is 1 step away, the decimal point will be here. This is 1 step away. If it is 2 steps away, it will be here. Alright? And if it is 3 steps away, like that. So from the question, it is 2 steps away. So this is the 0 position, 1 step, 2 steps, meaning this is where the decimal point is. Our final answer is 624.8 approximately. So when we use our logarithm tables to solve this, we got 624.8. Now if you punch this with your calculator, 25 times 25, you are going to get 625. So you can see that our logarithm table is an approximate way of getting the answer when you don't have a calculator. So 624.8 is what we've gotten. Alright, now let's move to the next example. So I'm going to leave this table because we still need it. Now, for this next example, we are going to use logarithm tables to solve for 76.7 times 308.2. Alright, so as I said, the first step is to draw this table, number and logarithms. The next step is to start filling in the number section one by one, as well as the logarithms. So 76.7, I'm going to write it, 76.7. Under logarithm means find the logarithm of 76.7. How do you find the logarithm of 76.7? To get the first part of the answer, you move this decimal point to the correct position. The correct position is always in between the first 2 digits. That is where it should be. So if you move these digits to the correct position here, how many times did I need to move to get there? Once. So that is 1 point. And then we go to our logarithm tables to look for the logarithm of 76 under 7. You take note, there's no fourth number to be a difference. So we don't have anything like difference 2, difference 3, because we only have 3 numbers. So those 3 numbers we got 76 under 7. And when you check that in your logarithm table, 76 under 7 is going to give you 8848. The next thing is to put our times. And under logarithm, times is what? Plus. The next number is what? 308.2. So how do I get my answer? Don't just jump to the logarithm table, guys. Always remember that your answer for logarithm is in 2 parts. The first part is gotten by putting this decimal point in the correct position. So if you notice, the correct position is supposed to be between 3 and 0. This is where we want it to be. But it is not there, it's far. So how many times do I need to move to get there? 1, 2. So our answer starts with 2 points. And then now I can look for the logarithm of everything. Don't mind the decimal points anymore. I will call this what? 30 under 8 difference 2. Alright? So 30 under 8 difference 2 gives me, first of all, when you check your 30 under 8, if you are following me with your logarithm tables, 30 under 8 is going to give you 4886. Alright? You're going to have 4886. And then if you continue under that same line, then you are going to have difference 2 as 3. Difference 2 will give you 3. So when you add it, you are going to have 4889. Are we together? So when you add these 2 numbers in logarithm, you are going to get your final answer in logarithm. Adding it is going to give you 4.3737. But we don't need our final answer in logarithms. When you finish solving here, always convert it back. Let your answer be as a normal number. How do you convert from a logarithm back to a number? You use your anti-logarithm tables. So when we use anti-logarithm tables, don't forget, for anti-logarithm, and don't let it confuse you, anti-logarithm is the one where the first digit, you put it inside your pocket. And then you go to your anti-logarithm tables and find the next 4 digits after the decimal points. So we are going to look for 37 under 3 difference 7. When you look for that, you are going to have 2, 3, 6, 4. That's what you get. I'm doing the whole process. 37 under 3, because 37 under 3 is 2360. Alright, the difference 7 is 4. So when you add 2360 plus 4, you get 2364. Now after getting this, you bring out this 4 that you put in your pocket. It will help us to know the position of our decimal points. Don't forget, this is the 0 position. This is the normal position it should be. Alright, but this is the 1 position. This is 2, this is 3, and this is 4. Meaning this is where the decimal point is. So what do? Since there's an empty gap here, that there was no number to fill it in with, you fill it in with a 0. Which means your final answer is what? 23640.0. Alright? So that is the answer you get when you use your logarithms table. If you were to use your calculator to punch this directly, you are going to have something like 23638.94. So you notice it's basically, they're approximately the same. This is 638, this is 640. So our logarithm and anti-logarithm tables help us to perform calculation of any numbers without having to punch in our calculator. I'm only using this calculator to confirm to you guys that this is what we are doing is actually correct, and you can even use it in an exam that you are allowed to use calculator to confirm if your solving here is correct. Alright, now let's solve the third example under multiplication. Alright, which is this 21.24 times 3000. The first thing, as usual, is to draw this table. Please guys, don't forget, practice makes perfect. When you draw this table, number and logarithm, you always put the numbers in this number side. Alright, so what's the first number? 21.24. Alright, 21.24. We are going to find the logarithm. For logarithm, the first step is always put these decimal points in the correct place first. Alright, and it's not in the correct place, it needs to move 1 step to get there. 1 step. So our answer starts with 1 point. And then you can now go to your logarithms table and look for what? 21 under 2 difference 4. So when you look for 21 under 2 difference 4, you're going to have 3271. Alright? And then times, because we are done with the first number, we found the logarithm. Times means what? Plus. 3000. 3000. Now this 3000, first thing is, where is the decimal point? Is it in the correct place? No. Because this is the same thing as 3000.0. So the decimal point is very far. How many steps do I need to move the decimal point to get between the first 2 digits? 1, 2, 3. So our answer will start with a 3 points. And then I'll go to my logarithm tables and I'm going to look for 30. Alright? 30 under 0 difference 0. Alright? When you look for 30 under 0, you are going to get 4771. 4771. I didn't bother looking for difference 0 because there's no difference 0. We only have from difference 1 to 9. Alright? Now, we'll have these two numbers. Is to add them up. When you add them up, you are going to have 4.8042. When you add these two numbers up, this is your final answer, but it is still as a logarithm. So you have to use anti-logarithm tables to convert it from a logarithm back to a normal number. Alright? We always use logarithm tables first to convert number to logarithm. But then we use anti-logarithm to convert a logarithm back to a normal number. Alright? So as usual, we always put this number. For anti-logarithm, you put this first number before the decimal points. You put that number in your pocket. Then you will look for the anti-logarithm of 80 under 4 difference 2. When you do that, 80 under 4 difference 2 is going to give you 6371. Alright? And then, time to bring out the 4 from our pockets. That 4 is going to tell us where to put our decimal points. So this is the 0 position. Alright? In between the first 2 digits is the 0 position. This is the 1 position, 2 position, 3 position, 4. So this is where the decimal point is. So we are going to fill this empty slot with a 0, which means our final answer is 63710.0. Alright? And if you were to punch a calculator directly, this will actually give you 63720. So you see that they are both correct to the nearest 100. Alright? So these are some examples of multiplication operation in base 10 logarithms. And I believe that it's straightforward. As you can see, it tests your knowledge of both using a logarithm tables and anti-logarithm tables. So please, if you find it confusing, check my previous video where I explain how to use an anti-logarithm table and how to use a logarithm table so that you can understand better. Alright? Now, let me give you some examples that you can try on your own on multiplication. Now try and multiply these two numbers. Don't forget the process. Always draw your number and logarithm table, and then look for the logarithm of some numbers. When you add them up, you look for the anti-logarithms. Alright, this is 22.2. So thank you very much for staying. In the next class, we are going to move to how to use logarithm tables to perform division operations. Thank you.